Good day, everyone. I'm Mr. Florendo, your Algebra 1 teacher. Today, we will discuss about operations with radical expression, that is in Chapter 10, Lesson number 3, textbook, pages 626 to 630. Materials needed: your textbook, your notebook, your pen. Our objectives for this class: to be able to simplify sums and differences of radical expression, to be able to simplify products and quotients of radical expression. To simplify sums and differences of radical expression, the first thing that we're going to consider is to use the distributive property to combine like terms. Example: if I will have 5x plus 4x equals to the quantity of 5 plus 4 times x, that is equal to, get the sum of the inside the parentheses, that is 5 plus 4 equals to 9, then simply copy the variable 9x. Second, we will use this same principle to combine like radicals. When we say like radicals, are radicals with the same radicand. For example, 3 square root of 5 and square root of 5. This is an example of like radicals. The third one: sometimes you will need to simplify the radical expression to see if you have like radicals. Example number 1. Simplify 4 square root of 3 plus the square root of 3. Are the expression here like radicals? Since we do have here the same radicand, these expressions are considered to be like radicals. So we will just apply the distributive property. So we will have already here 4 square root of 3 plus the square root of 3 equals to 4 square root of 3 plus the coefficient of the second term of the radical expression is 1 square root of 3. So both terms contain square root of 3. So they are already like radicals. Use the distributive property to combine like radicals. Add the coefficient 4 plus 1, then copy the radical expression square root of 3, and then simplify. 4 plus 1, that is 5 square root of 3. Second example: simplify 8 square root of 5 minus the square root of 45. Since 5 is already in the simplified form of radical expression, we're going to check the second one. Since the expression here are not like radicals, so we need to simplify the second one. The square root of 45 can be written as 9 times the square root of 9 times 5, the square root of 9 times 5. So simplifying that one, we will have 8 square root of 5 minus, apply here the multiplication property of square roots, so I can rewrite that one as the square root of 9 times the square root of 5. Simplify the square root of 9, so I will have 8 square root of 5 minus the square root of 9, that is 3 square root of 5. Then use the distributive property to combine like terms. 8 minus 3 times the square root of 5, and then simplify that one. 8 minus 3, that is 5, and then copy the radical expression. Simplifying products of radical expression. We're going to use distributive property, or simply the FOIL to multiply, or you can use the Punnett square model. Example: simplify the square root of 5 times the square root of 8 plus 9. So to simplify this one, I need to use only the distributive property. Square root of 5 times the square root of 8, so we will have multiply the radicands, that is square root of 40. Then square root of 5 plus times 9, that could be positive 9 square root of 5. You're not going to multiply 5 and 9 because 9 is not a radicand. We are going to multiply only here both radicands already. So simply use the distributive property. Then after that, simplify the radical expression. Square root of 40 is not yet in the simplified form. So we can find a factor of 40 that is a perfect square. So I can rewrite this one using the multiplication property of square roots. That is the square root of 4 times the square root of 10 plus 9 square root of 5. Simplifying that one, simplify square root of 4, that is 2 square root of 10 plus 9 square root of 5. Is square root of 10 in the simplified form already? Yes, because you cannot find a perfect square factors other than 5. What about square root of 5? Yes, that is in the simplified form. So therefore, the product or the simplified form of this one is 2 square root of 10 plus 9 square root of 5. Simplifying quotients of radical expression. To rationalize the denominator in a radical expression, example, removing the radicals in the denominator, we multiply numerator and denominator by the conjugate of the denominator. When we say conjugate, these are expression with sum and difference of two terms already. Conjugates are the sum and difference of the same two terms. Example, the square root of 7 plus the square root of 3 has a conjugate that is square root of 7 minus the square root of 3. So we have sum and difference of the same two terms already. That is on how we simplify radical expression by dividing. Example, 8 over the square root of 7 minus the square root of 3. To simplify this one, first step, we need to multiply the numerator and the denominator by the conjugate of the denominator. The denominator that we have here is square root of 7 minus the square root of 3. So times the conjugate of your denominator is the square root of 7 plus the square root of 3 over the square root of 7 plus the square root of 3. So simplifying that one, multiply in the numerator and your denominator, we will have this one, 8 times the square root of 7, that is 8 square root of 7 plus square root of 3 over square root of 7 times the square root of 7, that is square root of 49. The square root of 49, that is 7, minus the square root of 3 times the square root of 3, that is square root of 9. So what is the square root of 9? That is 3. Simplify the denominator, that could be 7 minus 3, you will get here 4. And then you can simplify 8 divided by 4. Divide 8 and 4 by the common factor, that is 4. So we will get that one, 2 times the square root of 7 plus the square root of 3. Or you could have that one as 2 square root of 7 plus 2 square root of 3 by distributive property. Since they are not like radicals, you cannot combine that one. Another example. A painting has a length with ratio approximately equal to the golden ratio 1 plus the square root of 2. The length of the painting is 51 inches. Find the exact width of the painting in the simplest radical form. Then find the approximate width to the nearest inch already. When we say golden rectangles, or the golden ratio that we have here, it is always in this form. 1 plus the square root of 5 is to 2. That is the ratio of the length to the width in a golden rectangle. So how are we going to solve this one? First, we're going to define 51, that is the length of the painting already, and let x be the width of the painting. So we're going to relate this one into the golden rectangle ratio, that is 1 plus the square root of 5 is to 2 equals to the length is to the width. So this is already the ratio and proportion of this particular problem. So we can derive that one. What is the ratio of the golden rectangle? That is 1 plus the square root of 5 over 2 equals to, what is the length of the painting? 51. What is the width of the painting? That is unknown, so we represent that one by x. By cross multiplication here, we will have x multiplied by the quantity of 1 plus the square root of 5. That could be x times 1 plus the square root of 5 equals to 2 times 51. That is 102 by cross multiplication. Dividing both sides by 1 plus the square root of 5. So I will have that one. X times 1 plus the square root of 5 over 1 plus the square root of 5 equals to 102 over 1 plus the square root of 5 to solve for your. So x therefore would be 102 over 1 plus the square root of 5. Since the denominator here has a radical expression, therefore it is not in the simplest form. So to simplify this one, we're going to multiply the numerator and the denominator by the conjugate of the denominator. The conjugate of your denominator here, that could be 1 minus the square root of 5 over 1 minus the square root of 5, that is to multiply your given expression by its conjugate. So simplifying that one, I will have 102 times the quantity of 1 minus the square root of 5 over. In your denominator, that's only 1 times 1 equals to 1 minus the square root of 5 times the square root of 5, that is square root of 25. What is the square root of 25? That is 5. Simplifying your denominator here, we will have 102 times 1 minus the square root of 5 over 1 minus 5, that is negative 4. Divide 102 and negative 4 by the common factor, which is negative 2 already. So we will get here negative 51 times 1 minus the square root of 5 over 2. You can use your calculator to simplify further. That is x equals to 31 minus 51, 97, 33, 43. Or that is x is approximately 32. So the exact width of the painting is negative 51 times 1 minus the square root of 5 over 2 inches, and that is approximate width of the painting is 32 inches. For other exercises, please refer to your weekly plan and your Pearson account.